Hello everyone, we are back again with another live stream. I'm sorry I'm little late. I was taking bath and I got late. I woke up late today. I don't know why, but yeah, I woke up late today. Yesterday I slept for from I guess I slept at 10:30 and I woke up at 8:30 in the morning. I slept a lot today. So, but finally I'm back and yeah, today will be solving another uh, questions. Basically, today we'll be picking up the questions from code forces, and we'll try to solve the questions on code forces based on some ratings. So currently, uh, last stream, I guess we solved 1200. Oh, okay. No, it's not 1000, it's 1200. So yeah, last stream we solved 8 questions and one question from this. So total 9 questions we solved from code forces, and we also solved from lead code. So today I'll be trying to solve more of a question based on code forces only. Because lead code I have already solved many of the questions, so I'm familiar with the most of the questions. But in code forces, there are lots of mathy problems which really confuses a lot. So if I'm able to solve those math related problems, it will really help me to grow my intuitions, to improve my ideas on how to approach to a problem. Because we have already solved we have already seen all the patterns based on which we'll be able to solve the question. But it's really comes boils down to something, your intuition, what your intuition is, like which one to apply, or how to apply, or how to approach to a question. It might be that those 14 patterns are only being applied on those questions, but you won't be able to figure it out. You need to figure it out how to apply this. So for those things we need to improve our ideas, we need to improve our logic, we need to improve our skills more and more. So the more we'll improve, the more we'll be able to grow. Because we already know that we have seen in past couple of weeks, the lead code contest has been the level of lead code contest has increased a lot. So I think we should also increase our level, because we already know there are lots of chat gpt and these all things. So if they go for the basic contest which they used to do earlier, we won't be able to like everyone will be able to solve uh, 3 questions at least and 4 questions at most very easily, like 3 questions from chat gpt, and they'll focus more on fourth question. And the cheating and all those things are really happening today a lot. uh, so they increased the level of coding. Now we need to solve it using our brain. We chat gpt also won't be going to help you a lot on those questions. So we need to solve it more with the help of your brain. just just a second. Okay, so so for that I'm picking up the code forces questions. We'll try to solve code forces questions. If we don't get the intuition on how to solve, we'll go for the solution. We'll see the approach and how they are solving, and we'll try to add it to ourselves. Like okay, they if these type of question comes, so how to approach to these questions. We won't be picking up specific topic related question, maybe we'll directly go for generic question and generic topic, and we'll solve that. So let's not waste any further time, and let me start my POMO focus. So again, this will be based on, we'll be starting with 50 minutes of coding, and then 10 minutes of short break, and after that in between I'll take a break, a longer break, which will be for lunch break, and after that we'll back to our coding stream. So let's start. All the best for you also, and I'll try to paste all the questions on the chat so that we will be able to, if you want to solve the question also, so you'll be able to solve it. Let me start my. Okay, let's go. So the question says, the first question that we will be picking is, you are given a positive integer n. Okay, I have been given a positive integer n, that's fine. Find the longest sequence of positive integer a. I need to find the longest sequence of positive integer a. Okay, that satisfies the following condition, and print the sequence. That means a of I, every value inside this array integers, I have to print a positive integer, list of integers, so it will be an array. So every element inside the array should be lesser than or equals to n, the n that will be getting. Okay, a is strictly increasing, a should be strictly increasing, that is a of I should be greater than a of I minus 1, means this element should be greater than the previous element. This is the condition, something like this. It should not be equal, it should be strictly greater than, strictly increasing. Okay, that's fine. And the third condition says is a of I or a of I minus 1 should be equals to n, means if I or these two, that should be equals to n. Every element, if I or it with the previous element, it should be equals to n, where I will start from 2 to k, obviously, bitwise OR operation. So I need to form an array. I need to form a longest sequence of positive integers where these conditions follow. The conditions are, the first condition says that the a of I should be lesser than or equals to n. Okay, that means the last element, because it's an increasing order, so the last element should be lesser than or equals to n. It should not go beyond n. That's what the first condition says. That's true, fine. The second, it should be strictly increasing. That means every element, the element before to that, should be a strictly increasing element. And the third condition it says is the OR of the two element, the element and its previous element, if we do bitwise OR operation on both of the element, it should be equals to n. Okay, there are lots of conditions that we need to follow, and then we need to find the longest increasing subsequence. So it's kind of longest increasing subsequence, but with some condition, specific condition. Longest increasing LIS that we used to see, but with extra condition. Now let's see a example, and let's try to understand the example. Okay, there is no explanation here, that's fine. So there will be 4 inputs, 1 2 3 4. First is 1, so we'll only output 1. So output is 2, like what is the size of the array and what are the elements, both I have to print. Okay, for the second example, it's 3. So so there are 3 element total of 1 2 3. See, the last element is not going beyond 3, and all the elements are in strictly increasing order. Perfect. And all the elements are in bitwise OR. So 1 with 2 bitwise OR, if I do OR, it will be 3. Correct. And 2 with 3, it will also be 3. Correct. So in any case, the answer is coming out to be 3 only. So this is what we need to follow. Let's go for the third and the fourth example also, test case also. Let's see what can we conclude anything from, can we extract anything, can we extract any idea from here. So we are given n is equals to 14. So we have 4 10 12 and 14. So the size will be 4 and the array will be 4 10 12 and 14. Correct. So one thing that comes to my mind, is it fix that there will be only this in our answer? No, it's saying that if there are multiple longest subsequences, you can print any of them. It doesn't matter. I can print any of them. So it's saying that we can print any of them. That means it's possible that the answer for one input can be many. Means I need to figure out. This might be one of the possible answers that we can come to, or it might be possible that we won't be able to come to this answer. There might be some other possible answer also. So our logic depends on our logic. Okay. Okay, let's see. Let's start. It's given n is 14. If I take the first number as 1, so the bitwise of 1 is 1. Now I need 14 in my answer. So the next number for 14, let me count the bits for 14 also. It's 8 4 and 2. Correct, right? So this is what we want in result. So for this to come, I need these 3 bits. See, it is saying it should be OR. Means I have to play within these 3 bits only. I can't set this bit to 1 anywhere. If I set this bit to 1, I'm 100% sure the answer will never come 14, because in 14 this bit is set to 0. So I need to play within these bits only somehow. I need to set 2 numbers. I need to take 2 numbers. In one, I can set one of the bits to 0. If I set the maximum, I need to start from the smallest number and go to the largest number. That's what increasing order says. So I need to pick a number which is smallest and the next number which is greatest, which is just greater than that number. That will be the rest of the bits. So if I set this bit as if I take a number like a and b, and ORing these a and b should be equal to should be giving me 14. So I need to set something. So it's this bit will always be 0. This bit will always be 0 for both of the cases. I only have to play within these 3 bits, right? Now the smallest number that I can take that I can pick here is, maybe 2. So if I take this as the smallest element 2, if I set this bit and rest of the bit to be 0, that is, this will give me 2 as the smallest element. So the next element that will be happening is 110, which will be nothing but 12. So if I'm taking 2, then I have to take 12. It might be possible that I even this bit is set for this number. It won't matter because this will be smaller and this will be greater. Okay, for 23, let's see if n is 23. How are we setting our sequences? That is one of the question. Like, for example, if we are taking a array which is nothing but a let's suppose what's the bitwise or of bit value of this 23, that is 16. 16 plus 8 will be 24, 0, 4, that is 20, and this, so 1 2 4 8 and 16. 16 plus 4, that is 20. 20 plus 2 plus 1, that is 3. So this is value for 23. I need to find the maximum sequence that I can create from this by setting the rules. So for this we know that we only have to do some changes or do uh, here and there with these bits only. Give me a second. Okay, so it's 1 1 1 and 1. Now how can I uh, approach to this question? So the first number that it is saying is 7. If I take first number as 1, a as 1, what will be my b? 2 4 16 will be 20 22. This is the last number that we are getting. Maybe we can start with the mid number, mid value, and then we approach and then we start to increase the value. So for 23, mid bit 1 2 3 4, 1 2 3. So the total bits our count is 4. So let's start with this bit. If I set this bit, it will be 4, 1 2 4, 4, and the rest of the bit will be 16, 18 and 19. I need to close the difference. See if I can close the I can close more the difference, the more number I can create. If I take if I start from middle and if I take these two number 5 6, it will be 6, and the rest of the two numbers are 16 plus 1 17, that is 17, 6 and 17, that will give me 23. So the next number that I need to take is 18, or the number like this two number was the biggest number that we took. I need to take one more number from this. Now these two bits are set for 17. I need to set these two bits. So if I take these three numbers 16, uh, 4, that's 20, and 22, that's 22, and in the next I take 20 all, that's 20, 6 17 22 and 24. Can you check if any of them is violating our answer? 22 and 17. For 22 it's 16 20 this, and for 17 it's 16 0 0 1. This will give me 24, correct? It is also following our answer, what we did over here. Somehow we also found this as our solution, but what we did, there is something that I can see over here. Okay, if we close out the more close out the difference, the more optimal will be holding. So the last set bit, just take the example of this n. So the last set bit is the largest value. If I consider only this as 1 and rest of all 0, this is the largest value that we can attain if only one bit is set. So I need to close out the difference. If I close out the difference, I will be able to get something out of it. Maybe, let's see. If I take rest all the bits, so 1 1 2 4, this is 6 6 and 8. We took these two and this, so this is 6 and 8. And now what we will do, we already know that this bit is set. I need to set these two bits in the next element. So if we take the next element, if we leave the last element, start and last, and take the middle element and take rest of the elements, what can we conclude? Anything like if I take this and this, so this will be 4, this will be nothing but 9, correct? 8 no, it's 10, this will be 10. Now I need a value uh, greater than 10, so I need to include this also. Hmm. So the last number contain these two elements. So the next number can be these two. 10 plus 4, 14. It will be 14. 8 plus 4, that is 12. And then all 14. Means there will be this number will always be there. Whatever n value is, n will always be there. Hmm. What is how much n can range up to 10 to the power 18. N can range up to 10 to the power 18. That means it's really going to be humongous. I cannot iterate over each number, and I need to somehow set bits and like okay, we were doing from left to right. Let's try from right to left. Now we know the last digit is 14. We always know that the last digit will be the n only, because every number I need to reduce a number. Let's remove this, because 14 will contain all the bits. So if I remove even this bit, the smallest bit, it will give me a value which is just smaller to 14, which is 12. Now I know that this bit has been removed. Now what I will do, I'll remove this bit, but I'll include this bit in our answer. So this will give me a value 10. Now for the last number, I know that this middle was removed. These two are there. So if I somehow remove, if I want to remove this bit, so in the last test case, this bit has also already been removed, correct? Now I need to remove, if I'm removing this bit, I need to include this bit. So if I'm including this bit, what will be the value? Like 4 plus 1, 5. Because I'm removing this bit. So 5, 10, 12, 14. Is it correct? Let's see. We have 5. We have 5. Correct. We have 5. What's the value? 4. No, no. It's 6. 4, 2, 6. Sorry. For 6 it will be 1, 1, 0, 0, and for 10 it is uh, 8. This will give me 1, 1, 1. 10 and 12 will give me 1, 1, 1. 12 and 14 will give me 1, 1, 1. That's fine. Okay, we can go, instead of going from start, let's go from behind. Maybe that will help me. So we have 23, so we'll keep 23 as our answer. Now this is my 23. If I remove the last digit, I know this contains all the digits, so 22. Now for 22, this last digit is not present. I'm sorry about the background noise. I can't do anything for the background noise. So for 22, I know the last digit has been removed. Now what I will do, I'll add this last digit in the number and remove this bit in my number. So what will be now? 2 will be removed, so 21. Correct. Now I'll add this also, and I'll remove this bit only. So what will be my answer? 16, 18, 1, 19. 19 will be our answer. And I add this bit also, and I remove this bit from our answer. So what will be? It will be 1, 2, 4, 5, 6, 7. 7. 7, 19, 21, 22, 23. 1, 2, 3, 4, 5. Total 5 length we can make. And if we go from right to the start, we'll be able to solve it now. Oh my god. So why didn't I get this at start only? Instead of going from start finding, let's see. So we have 7. 7 is 1, 1, 1. And everything is 0. 19. For 19, what we can see is for 19 have 16, 17, 18 and 19. This will give me 23, 19 and so this is 19, 19 and 21. 21 will be 16, 16 plus 4, 20, 0 and 1. This will also give me 24, 21 and 22. This will also give me 24, 23, 1, 0, 1, 1, 1. Will always give me. Oh my god. Should have thought about it earlier only. Like, can't we go from back instead of going from start? My god, there are lots of bugs that they fixed. Nice. Sublime.log commands. Logging functions are not toggle when no argument is passed. What is this? I should do something which will tell me what rating this is. I knew that. Sure. Save it. Now it's fine. Just give me 1 minute. I'll be back in 1 minute, 1 or 2 minutes. I'm back. Sorry. Okay, let's code it. So we'll get something as n. We'll take this n. Now I need to find the largest sequence possible. Okay. This let's call it solve and pass this n to solve. I'll take integer. It was should I take long? It should I'll not pass anything. I'll just print it over there only. No, I need to store it in an array. Correct. Maybe LL. Let's now. What I will do, I'll start from bits, setting bit and removing the bit. So I need to pick bits. Okay. I'm thinking of something easy way to do all the bitwise stuff instead of going for something very long. Process instead of, I don't want to store the ones in somewhere and then do the operation. Like I know there is a number n. I'll start from n. I'll right shift it until and unless I find a 1. I found a 1. Uh, and I'll find the place where that 1 was. Now I know the place where that 1 was. I need to toggle that. Now toggling that bit. Now I need to toggle specific index bit. Is there some way? How can we toggle specific bit in C plus plus? That XOR will do. That number XOR with 1 left shifted and extends. Correct. Sorry. What in the world I was thinking? I should have those toggling should have been easier, huh? Okay. Let's see. I'll create a temporary variable which will start from n. Now int I will start from 0. Now I need to somehow stop my loop also. Okay. And I need a vector int answer where I will store my answer. So answer dot pushback n will always be in my answer. Now let's go till 32 bits. That's the maximum that I can go. I0 I is lesser than 32 plus I. So remove this I. Now what I know, I need to check whether that bit is 1 or not, set or not. So int number will do what? I'll do XOR with, not XOR, I will do AND, one AND. Now this will be in if condition. If n and it with 1 left shifted I times. Okay, is giving me 1. That means this bit is set. I need to toggle this bit, and whatever the value will come, I'll push it in my answer. So toggle this bit. Do toggle this bit. So for toggling this bit, what I will do, I'll store a num. This will be my answer. N will be nothing. Now XOR this with 1 left shifted I times, which will give me a number. Now answer dot pushback number. And I can go for 32 times now. Reverse answer dot begin, comma, answer dot end. After reversing, I'll print this. Switch to 0, I is lesser than. First, what I have to print, I have to print cout answer dot size /n, and then cout answer of I. Do we need space? What got closed? Shit, my timer also went down. Yeah, we do require space. Did I do something wrong? Did I do something wrong? What do you think? I did 1 left shift I times, so 0 left shift and it with n. If I'm ending, that comes out to be 1, that means that bit to toggle that bit. If n XOR 1 left shifted I times will give me a number. For 4, for 2, wait a second. It's 23, 22 only. For n is equals to 3, for n is equals to 3, I know these two bits are set. I've already pushed 3. If I remove this bit from 3, what will be left? 2. It's fine. If I remove this bit from 3, what will be left? 1. It should be 1, 2, 3 only. It's fine. I should be getting 1, 2, 3. But why I didn't get for 1? So the number should be greater than 0, right? I need to check that thing also, that the number should be if number is greater than 0, the num should be greater than 0, then only I'll push it in the array. For 1 it's 1, for but why? Let's take only this should not be the case, right? Let's take only 1. It's 2 and 3, why not 1? For 3, 2 bits are set. Already pushed n. I left shifted 1 0 times, that will be 1 only. I'll do something. So I see out 1 left shifted I times, and let's not print this. So 1, 2, 4, 8, 16, 34. It's correct. You can even take LL. It doesn't matter. Hey, it was coming 1, 2, 4, 8, 16. store it in some variable. Value is one left shifted I times. And now and with val, if it is giving me 1L. Hey, why not? One is coming, bro. Uh, LL. Let's take everything as LL. Exorval. No, still not. Okay. When my bit is 1. Okay, let's take something as temp XOR val, and every time temp updated with n. First time it was 1. Second time I shifted it to, which is 2. And now if n and with 2 should give me 1. What is the problem? I'm sorry. But now it's not even going in inside. N and with val. Only once it is going when my value is 1, but when my value is 2, is my temp val over here, and after doing this, what is my temp value over here? My temp val over here is 3. My temp val after doing this also is 3. So when I became 1, val became 2. Now temp is again 3. So 2 and with 3 should give me 1. Correct. Is there anything missing logic? So like 2 is nothing but this, and 3 is nothing but this. Adding it will give me a number which is greater than 0 but not 1, greater than 0. And now why it is going these many times inside? Hey, this should not go these many times inside also now. What the hell? Is there any more C out that is there? It's 32 times it's going inside. Now what happened? I have 3, that is this. Now I 1 left shifted 2 times, 0 1 and 2, it 1 here, 0 0 0. If I add these two, it will be 0 0 0 0, and if the number is greater than 0, it should go, but if it is not, it should not go. If it is not equals to 0, what? And with val, Every time it is 0. Why it is going inside now? The numbers are 0. Oh my god. Is it something related to integer and long that I am doing? If I shift everything back to integer. Why? Why the output is 0 and this condition is saying why it is going inside this if condition? I'm saying when these two is greater than 0. Great. It's coming out to be 1 2 3. If I take 3, 7 19 21 22 23, and if I take 4 and 1 over, it's 1. Okay. Wrong answer. Integer parameter name a1 equals to minus violates the range. It's the problem with the range. The values. Okay, it's because of this ll and long and integer. If I take ll, let's take ll. On test, what I tested over here, the output is this only 7 19 21 22 23 5 long hack. unexpected end of file. Int 32 expected test case 1. What? My code is. Oh, wow. Wow, 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 wow. I submitted some other code. This unders. Again, same. Wrong answer, not longest test case 101. For 32, it's 10 to the power 18. How many bits? Test case 101. Hey, saying wrong answer, not longest. Test case 101. Why it's not longest? times is 100. It is increasing. Why it will be not the longest one? Am I doing something wrong related to is my solution wrong, or one, two, three, four, five, six, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 10 to the power 18. This is what so 10 to the power 18 is done. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And 8 is not the longest. For this, how can I check? For this, how can I check what my answer is coming? I don't have to run, I can't run any test case. The problem is this. This is a solution discussion. Can I have obviously the answer only depends on the popcorn. Obviously that is what I'm doing. What is the total built-in pop count? For this, let's see. BILT built-in pop count. Integer number. Let me do this. Let's let's not call this print ILT. So built-in popcorn for this is 8, and it is saying the solution is also saying that it should be equal to built-in popcorn when it's on the pop count of n. It is the input. X 1 is left shifted I times, and now x with n, if it is equals to x, and x is not equals to n. uh, 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 अच्छा is there any expected answer over here? What is this file? This is an input file. What is the status? Okay. Maximum length for 2 to the power k minus 1. K is greater than 1 is k plus 1. The answer is a simple construction. It is shown in the samples that the length is 1. Consider the value of a of 1. a1. Consider the value of a1. Note that its kth bit indexed from 2 to the power 0 to 2 to the power k minus 1 should be 0, otherwise we won't be able to make it. Okay, not sure. Let's see the solution, video solution for this. After a short break, I'll take a 10 minutes of break, and then when we'll come back, we'll see the video why I was not able to do it. Let's see. Okay, I'll be back after 10 minutes of short break. I'm back. Okay. I don't know what Python is. Let's try this once more. I have been given this n in D. We created a array, empty array. Range 62 minus 1. I don't know what these all minus ones are. Um, if you know, do let me know. It's fine. So what I'm doing is I'm taking an x where 1 is left shifted I times, correct, and then I'm modding ending with n, and if it comes out to be x only, that means that bit was set and that x is not equal to n, correct. So a dot append okay, a n minus x. If I do n minus x, that's the same thing if I or I do n XOR x, that bit will be removed, and then I am appending it. Sorry, a dot append n minus x. Those are the numbers that I and at last I'm appending the n. And then I'm printing the value. What does this mean? Hey, it's the same thing that I am doing. It's not something different. To whom should I ask? Let's ask ChatGPT. Starting from 62 down to minus 1 inclusive with a step of minus 1. Starting from 62 and down to minus 1. It's going till 62. But this will repeat the answer, don't you think so? Okay, let's see. Let's see if I somehow run this Python code. Python compiler. This t is equals to 1, n is equals to Will it run? For this, it's coming out to be the logic is same. There's nothing different in the logic. It's 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 simply the range, the number. It's so large. I'm applying the same logic. I'm not even doing any long. It is not taking long. It is going from 0 to 6 till 62. Maybe if I take double, uh, even that is going to help me. I'm not sure. Okay, see, the logic is very clear. Double is equal. Ah, I'm pretty much sure the logic is same. Nothing is different. The only thing is the range, and that is what giving me a problem. Well, then I suppose I should not solve it in C++. This question should not be solved in C++. maybe that's why it is in Python. But I know how it works. I know how it works. Okay. Let's now go to the next question. So the next question says T prime. T prime. The package for this problem was not updated by the problem writer or code process administrator after we have upgraded the judging server to adjust the time limit constraint or solution. Time will be multiplied by 2. For example, if the solution works for 400 ms judging servers on judging servers, then the value 800 ms will be displayed and used to determine the verdict. Oh. Okay, no problem. Let's see. It's saying we know that prime numbers are positive integers that have exactly two distinct positive divisors. Similarly, we will call a positive integer t a t prime if it has exactly three distinct positive divisors. If it has exactly three distinct positive divisors. Positive. We know that the prime numbers are positive integers that have exactly two distinct positive divisors. Similarly, we'll call a positive integer t as t prime if it has three distinct positive divisors. How many numbers are in the array? The next line contains n separated integers. Please do not use modulo LLD specifier to read or write 64-bit integers in C++. It is advised to use C in Cout streams or this specifier. So this is the input. So for 4, how many positive divisors are there? That is 1, that is 2, and that is 4. That's fine. For 5, how many positive divisors are there? 1 and 5, nothing in between. It will be something go till square root of the number and find the divisors, total divisors. If it is uh, more than 3, then see out no. If it is 3, see out yes. I think this question is not that difficult. It's easy just to iterate over the array and go till go from 1 till square root of that number included, though both will be inclusive, and check whether modulo, if I'm able to divide it or not. If modulo is 0, then that's fine, we'll able to divide it. Okay, just a second, let me close the door. It's the background brightness is very more. Just a yeah, now it's fine. So I think I should not, I will not be solving. It's only the long and those things needs to be handled, but the logically it's not that difficult. So you can directly jump to the next question, Sophia and the lost operation. Okay, this is a bigger question. Okay, let's see. Maybe if you want to solve this, you can try this, or you want to solve this, you can try this one. So the question is Sophia and the lost operations. Okay. So the given is, we are given Sophia had an array of n integers a1, a2 till an. From a1 till an we have array of n integers. One day she got bored with it. Okay. So she decided to sequentially apply m modification operations to it. Okay. Each modification operation is described by a pair of numbers CIDI. That means the element of the array with the index CJ should be assigned the value DJ. Okay. That is, perform the assignment A of CJ is equals to DJ. After applying all modification operations sequentially, Sophia discarded the resultant array. Okay. Recently you found an array of n integers b1 to bn. You are interested in whether the array is Sophia's array. You know the values of the original array as well as values of d1 to dm. The values c1 to cm turned out to be lost. Okay. Is there a sequence c1 to cm such that the sequential application of modification transform it to the array b1, b2, bn? Okay. There is no explanation for this. The first line of test case contain n, that is how many integers are there. The second line of test case contains A1 to AN, the elements of original array. Okay. Question of modification operations even transforms it into the array. Okay, the first line and contain the second line of test case contains A1, A2, AN, the elements of the original array. The third line of each test case contains any integers B1, B2, Bn, the elements of the found array. The fourth line contains an integer m starting from 1 to 2 into 2 dot 10 to the power 5, the number of modification operations. The fifth line contains m integers d1, d2, dm from 1 to 10 to the power 9, the preserved value of each modification operation. Of m for all test cases does not exceed. Okay. The fifth line contains what? I was thinking something else. Okay. I need to apply this CJ. This index should be assigned to some DJ value. Now C1, C2, Cm turned out to be lost. The element of the original array, the element of the found array. An integer. The first line of each test case contains the size of the array. Third line of each B is the fourth line contains M, the number of modification operation. The fifth line contains M integers d1, d2 till dm. The preserved value for each modification operation. Sorry, got lost in this lost operations. See, I was not thinking of the question. Okay, now let's think of it. M modification. Say she is applying M modification. So first array, second array, fourth M modification, and the fifth line contains integers M d1, d2, the preserved value of each modification operation. So we are given the array A, we are given array B, we are given array D. What I need to find? The A, she decided to sequentially apply M modification operation, each modification pair of Ci dj. So there is something missing, which is C, which is which index to pick and replace this value of A to this, and it will be B, something like that. The element of the array index Cj should be assigned a value Dj, that is perform the assignment this after a modification application. Sophia discarded the resulting array. We found an array of n integers b1, b2, bn. You're interested whether this array is Sophia's array. You know the values of the original array. I know the values of the original array. That's fine. As well as the values of d. I know b also. I know a also, I know b also, I know d also. The values c1 to cm turned out to be lost. So I don't know the value of this. Is there a sequence c1, c2, cm such that the sequential application of modification operations c2, d2, cm, dm to the array a1, a2, am transform it to the Is there a sequence c1, c2, cm such that the sequential application of modification operation c1, d1? Okay, I need to find sequential operation of these two on the array A to transform it to Bn. Okay, so the first and foremost thing, the uh, values over here should not increase the length of the length of A, because C is the index and D is the operation. So C is the index, so C should be in the range. I know A, I know B, I know D, I don't know C. C contains the index, it contains the index where I need to apply this value, and this is where we are applying, we are replacing the value. And this is what my resultant is after being replaced. This index, this value changing here will be equal to here. So 1312 means D must contain, it should not contain a value which is different, and B should not contain a value which is different. That means B and D, the values inside B and D should be same, right? If the values inside B and D are same, or at least the frequency should also be same, at least D should contain once that frequency, like whatever frequency it. See, B, D might be possible that there is only one operation that we did, and after that we came out to be a resultant. Means D should not contain a value which is different than B, but B can contain a value which is different than D, right? Because we are applying, maybe we are applying only one operation, so D should not contain a value which is different than B. That's one thing that we need to understand, that we need to follow. Now A uh, array A is being replaced directly with D. I don't know C. Do I care even of constructing a C? No. I need to make sure that D should contain whatever value D contains must be present in B. So in the first case, if I see this is my A, this is my B, this is my D. So 1 3 1 2 1 3 2, they both are containing same value. In this test case, I see 2 3 and 2 3 are contained over here. That is correct. Okay. So this one turned to be 2 and this 2 turned to be 1. Now here if I see this 1 and 1 remained same, that means if I replace if I use this 1 for this one, I can use index 0. Replace index 0 whatever value with 1, it will stay same. For this also replace with index 0, it will stay same. For this I am replacing from 2 to 3. So this 3 can be used over here at index 1. If I replace the value at index 1 from 2 to 3, this will be my, and for this if I use the index 0 2, so 1 will be replaced with 2. So there are two places that where the values are being changed. So I need to make sure these two places are being handled in D, means there should be a value 3 and 2. And the frequency of 3, if it is even 5 times, I don't care, I'll replace the same index again and again. And the frequency of 2, if it is 5 times, I don't care, I replace. If now suppose 1 2 2 1 1 was there, now this is 1, this is 3 3 and 2 2, suppose this is the case, so I need at least 3 2 times. 3, we require 3 at least 2 times. If it is only 1 time, I won't be able to do it. Isn't it? If 3 is only once, I won't be able to do it. 3 need to be 2. And if also 2 is lesser than 2's frequency should be greater than or equals to 2, I will be able to make this, but I won't be able to make this, because if there is only 3 ones, I'll use this 3 to replace this 2 to 3, but this 2 to 3 I can't replace, right? So the frequency should be same. That's another thing that we got from here. Now let's see what values are being replaced and what we need to do, what can we do. So see, 1 is being replaced to 2, there's one replacement over here, one replacement 2 to 1 is here, two replacements are there. and the values are 2 and 1. So I need these two values to be present in my D at least, and even the frequency is one time. But I can see 2 and 3 are present, so this is not possible. Okay, fine. So this is being replaced. There's one replacement, there's two replacement, there's three replacement that needs to be done. So what I want is 3's frequency I need in D once. I need 11's frequency to be 2 times. I can see 3's frequency is 1. I can see 11 frequency is 2 times. Even 4 is also there. See, the code break over here only. That 11th frequency should be 2 twice, because it has been replaced twice, but it is not. It might be possible that there would have been 1 and 111. If this is the case, 11 is twice, 3 is once. Now the rest of the numbers should be present in B, right? If it is present, I don't care about that, because I can replace the same number again, as same index number again. So the first thing, that whatever value B contains should be there in whatever value D contains. The first thing is, one is whatever value whatever value D contains should be present in B also. And the second thing is, frequency wise I need to pick it up. So, okay, so let's erase everything and start everything again. Starting, first one was yes, no, 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 and yes. Okay, so let's take these two and check. So for this case, let's see, the first is being 11987210.4. So 1 is there, 9 is there, 8 is not there. It's a no. Why the third? 2, 3. Why fifth is yes? I can't see 8 over here. Why it's yes? Is it that that I am applying or not applying? So after applying all modification operations sequentially, so after even applying all the modifications sequentially, let's see the second case if it is happening or not. So the 57179, so all the values are not present over here, that's fine. What are difference? They are different. This has been modified, so fourth frequency should be 1. This also has been modified, so 10 frequency should be 1. 1 has not been modified, this has been modified, so 2's frequency should be 1. And so 4 frequency at least 1 is there, 10 is there, 2 is there, so these 3 operations are there. And for the rest of the operation, for 1 I can use the same number, for 9 I can use the same number, and for 8 it might be possible I changed our index to 8 and then to 9, like changed it to 8 and then to 7. Means these 3 values were there, right? Now there's one thing that you need to remember. 1 I'll use these to 9. Suppose I replace the number 7 with 9, so instead of 7 it was 9, and now I replaced it with 2, right? I used 8, even I replaced it to 9 and then 8 and then all the things stuffs we did, and then I replaced back that number to the number. But if 8 would have been here, then this will be a no. Why I'm applying it sequentially, I need to apply 8, but if I apply 8, answer array will not contain it. Okay, this thing also that needs to be handled. Means the ordering also matters. This has been replaced, this has been replaced, 3 positions has been replaced, 203 is twice, and 1 dot 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 is twice, but I can see only once present over here, so not possible. So the frequency thing is I think hopefully it's perfect. 1 is being replaced with 1. Now you see, I need 1 frequency to be once if possible, so 1 frequency is twice, but this is also true. Why? I replaced 1 with 1, then with 3, then with 4, then with 5, and then at last I replaced it with 1 again. And now if I would have been given 5 again, I would have replaced that 1 with 5 again, and that will because of that my answer would have suffered. Means after all the replacement, I need to check. Even I need to keep this one also. It might be possible that this is present, and it might be possible that this is not present. This has been modified or this has not been modified. It doesn't matter. So if it is present, let me add it in my answer at the start only. Let me add it in my answer at the start only. Let me add it in D at start only. Doesn't matter. It might be possible that this would have been 1 1 and 2 3 4 something. I'll add 1 in my answer, so that means that this is possible. But after that I can see there are few replacements which I don't want, which is not even there in the array. And if it would have been 2 2 3 3 4 4, so 1 2 3 4, correct. Now this would have been 4 and this is 3. 1 I need 1, 2 I need 2, I need this 4, I need this 3. So 1 it is there, 2 it is there, 3 I need, so its frequency went down to 0 0 0. 4 I need. Now suppose if there is a 5 or suppose if there would have been a 5, if condition, if 5 is here, uh, if 5 is here, I could have replaced any of the number with 5, any of the number which is going to be replaced. And if suppose there is only one modification, that is 1 1, and if there is nothing in my array, only 5, so if they are same I'll add 1, they are same I'll add 2, so 1 is replaced, 2 is, now 5 need to be replaced somewhere. Okay, okay. So I hopefully this should work. If they are same, I'll just push it. If they are same, I'll just push it. I don't care if it is present or not. But this should be at the top, at the start. Fine. Okay, let's take a 10-minute break, and after that, when we come back, we'll start to solve this question, code this question. We'll be back in 10 minutes. back. Sorry, a little late. Okay, let's code this. So what we concluded is we need to track somehow. Let me say, wait, Sophia and the last operations. Last operations. It's 1300.cp. So this time we'll get few more things. First is n. N is what? Length of the array. So I will declare a vector int a. I need a b also of length n. I need a b also of length n. Can you give me 2 minutes? I'm sorry, but I need to give my garbage out. I'll be back in 2 minutes. I'm back. Sorry. Okay, so we declared the two array. Now what else we require? We require M. So let's first take the array A, C in A of I. C in B of I. Fine. I need an M, C in M. I need to declare another vector which is D of size M. So for int I is equals to 0, I is lesser than n plus I. C in D of I. Okay, uh, let's conclude something with the logic that we are using, so that we can code it properly. We need something to be concluded over here. The first thing, uh, let's keep everything in a map for this. Let's keep everything of D in a map. Let's see for this case. Okay, let's see for this case. So one frequency is twice, then comes 9, then comes 8, then comes 7, then comes 2, then comes 10, and then comes 4. Okay. So this is my D, which I have kept in my answer. That's fine. Now let's iterate over this. 5 and 4, there is a difference in array, so I need 4 to be there. Is 4 there? Yes, 4 is there. I'll reduce the frequency to be 0. Now 7 and 10, they are different again. So is 10 there? Yes, 10 is there. I'll reduce the frequency to 0, and the frequency should also be greater than 0. Correct? Now 1 and 1, they are same. So even if it is there, reduce the frequency, doesn't matter. If it is not there, doesn't matter. I may modify, I may not modify. So the frequency turns out to be 1. Now 7 and 2. So is 2 there? Yes. Reduce the frequency to 0. 9 and 9. They are there. There it is present, but if it would have not been present, not at all a problem. Now I can see there are few values, that is 8 and 7 and 1, whose frequency has not yet been converted to 0. Now I need to check the index of these frequencies, these numbers. See, 1, it won't matter even if it is there or not, doesn't matter, because 1 converting to 1 is not a problem. So 1 I can convert it to 0 directly, not at all a problem. Now 8 and 7 is left. There are two numbers which are not present in my array, this. So I need to check that their indices should be before at least any one of the value. Means what? I need to pick the last index value whose which can be changed, which can be used to change. Means every number's last index should be also present. So one last index is 2, 9th last index 0 1 2 2, so it's 1. 9th last index is 1. 8th last index is 0 1 2 3. 7th last index is 4. 2's last index is 5, 10 last index is 6, and 4th last index is 7. So the last modification that we did is in on index 7, and 8 and 7 are here, are values which has not been converted. So 8th index is 3, which is lesser than the last index. 7th index is 4, which is lesser than the last index. So what I can do is I can convert uh, this to something. Okay, so this way we will be able to do with using two map, keeping track of the last index that we want. So I will create a unordered map. Sorry, where I was searching. Unordered map, which one map will contain the frequency and another map will contain the last index. Now what I will do, I'll iterate over this array d dot size. Instead of d dot size, I should take m plus I. Inside this frequency I will do d of I plus and the last idx of d of I should be equals to I. This will do the work. I just need to handle if the values are same. I might handle it beforehand, or might handle on the go or after. So anything can be done over here. So let's see how can we do it. I will start with n. See, if a of I is not equals to b of I, if this is the case, that means there is a change. And in my D map, if that value b of I value is not present, I'll see out no and I'll return. Now if frequency dot find b of I I would say if frequency of b of I is is uh, is n- is lesser than or equals to 0, if this is the case, see out no and end L end L, come on, and return 0 maybe. Else what I will do, I'll reduce the frequency if frequency of b of and also I need last change index. So if this is not same, I need to know the last change index. So last change index is equals to maximum of last change index or last index of b of I. And if the numbers are same, there is one thing, if they are not same, I need to have that number. If they are same, if a of I is equals to b of I, so if it is not there, the frequency of b of I is greater than 0, then also this will be there, and frequency of b of I will be equals to 0. Can I set it to 0? Once I found out and set that value to 0, set its frequency to 0, because I've already checked, and if we find it again the same number, and if it is not present in map, we don't care about it. Now setting it to 0, now auto it is equals to frequency dot begin, while it is not equals to frequency dot end. Now if it second is still greater than 0, if it of second is still greater than 0, that means this number never occurred. So if it of second is greater than 0, so I need to check if last index of it of first is greater than the last change index, then I will be C out. Doing C out no and return 0. If not, then I'll be increasing IT plus plus, and at last I will print yes with a endl and return 0. Let's take a test case. Hey, it's still running. My god, why it took so much time? 28 seconds. And everything is yes. Why? Well, I have to check whether all the values are coming correct or not. C out N. C out M and L. Let's see. 64228061999136. What? What in the world is C out T T7. Oh, okay. I haven't. I did not take N. 3 and 4. 4 and 2. That's fine. No, it's fine. Yes, no. Yes, no, yes. Okay. Yes, no. Yes, no, yes. Now let's test it after. Maybe let's add 5. and 6 again. Turned out to be no. Is it going to create a problem? It's the question, Sophia. Sophia and the lost operation. I'm not 100% sure that it will be submitted or not. Okay. Yes, count is 3, no count is 4. Wrong answer expected, yes. Found no on 21st token. I think 21st token. Ah, 21st token. Now can we check 21st token? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I don't know if 21st token is also there or not. I'll have to check. Now if times is equals to 20, 2 string a of I. D of I. Seven six one 10 10 3 6 1 11 11 4 3 1. ठीक है. कौन सा टोकन? 21st token. Sophia and the last operation. There must be some problem with, I think, if it is same. That's what I am thinking. come on. On 21st token, but 4 found. 4. Okay, the number starting from 4. Hey, here it is. Here it is. It's something. Let's remove it. 42443514. On 21st token, what is expected is a yes. That's what I think it's saying. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 19 20 21. 21 it's yes, it should be yes, and mine was no. Why, let's see. 3's frequency is 1, 5 frequency is 1, 1 frequency is 1, 4 frequency is 1. Now 3's index is 0, 5 index is 1, 1 index is 2, and 4 index is 3. Perfectly fine. Now there is no change, but is present. Yes, it is present. Its last index is 3. So the last IDX is changed to 3, and this is converted to 0. They are not same. See, got stuck with same numbers. Got stuck with same numbers. Again, if the numbers are same, I'll have to handle this part separately. I can't handle it. I should not handle it together. I knew that this will come. This will come. I need to handle this separately. But how? Okay, if I if I'm not handling it right away, I'll handle it separately outside. Now what I will do is I'll check all the values which are same and it is present in this, and its frequency is not 0. So I'll convert it to 0. I'll pick that last index and do it in the second iteration. Let's comment. So if it is same, let's not handle it here. Let it be. Now do the same thing again. Now if EIBI is there, now if it is there, okay, let's add this test case also. So the test case is first size, that is 2, a is 4 space 2, b is 4 space 4, c size is 4, m size is 4, and the values are 3, 5, 1 and 4. Now it's yes. I'm handling the equal to part separately. Let us see. Will it fail or will it pass? Don't fail, yaar. The time limit exceeded. But why? This is O of n, and this frequency map n. The overall time complexity of O of is O of n. I'm even passing it with ampersand pass by address. Why it went to time limit exceeded? 2 into 1, 2, 3, 4. I'm not even using the size of the array. The first line of each test case. These are values of the array. That ranges up to 10 to the power 9, doesn't matter. M is 2 into 10 to the power 5. Right, there's no nested loop here. There's no nested loop. This is this will go 10 to the power 5. This might go 10 to the power. 5. And this also will go 10 to the power 5. Like if frequency of b of I is equals to 0, frequency dot erase I'm iterating over the frequency. Frequency dot erase b of I don't need that. And instead of making it 0, frequency dot erase, I only want the values which are not it won't affect our answer, right? Come on, Sophia. How can I reduce it more? Like I have 3 loops that are running. I may reduce it to 2 loop or even 1 loop. One loop possible? No, 2. Let's try for 2 loops. This one which is I am handling separately. If last index IT first is greater than last change IDX, so C out no. And if it's somehow I am able to find it without iterating over here. Will we be able to? Will we be able to? यार, how to reduce the time complexity? More. I need more. Uh, I need less time complexity. Okay, these things, this and this. Can this be handled together? See, if I create a map and add all the values of b, so I only need, if the value is not present in b, this is what it means. This is what I am iterating over here. This means that there was some value which is present in d which is not present in b. I need to calculate the index. B map. Let's make a b map. So when I'm going through all, iterating through this, I can populate my b map. B of b map of b of I. No, no. This will create b map of I already have d. If I somehow populate b map of b of I plus plus, I am doing this and not found last idx is equals to 0. I've whose frequency is also this, but even it is present, its frequency is greater than this, won't be mattering. Now if b map dot find d of I is equals to b map dot n, that means this value is not present, so I'll update not found last index with this index. So instead of iterating over whole array, whole map, I'll do what? If not found last index is greater than last change index, then see out no. Yes, no, 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 yes, no, yes, yes. If this in this I'm not iterating the whole map this time, but still I have some. It's not proceeding, it's still time limit exceeded. I don't know why. There's no conclusion for this. Why it is increasing? Even I'm going O of n. Do I have to reduce it to log n now? Can't. Okay, no problem. Fine, I'll take a break, lunch break. I'm feeling hungry now. So I'll see you after lunch break. Bye. Sorry, I went outside for having lunch. For that reason, I came late. So let's solve now without wasting any time. T primes now. So this time limit exceeded. What can we do? Sophia and the lost operation. Is there any tutorial? Sophia and the lost. First, in the array B1, the number DM must be present. Second, if AI is equals to BI, we will not apply any operation of I to I. All extra operation can be applied to AJ, where BJ is equals to DM. They will be overwritten by the operation DM for all. The operation remains to check that the multiset of BI include using sorting and 2 point. What? This solution can be implemented using sorting and 2 pointers. If you used unordered map or dict, you were most likely hacked. And that's what I did. Okay, why? C++ has always had the convenient data structure set map, which are T data structure whose operations take O of log and time. With C++11, we finally received a hash set and hash map on order. Unfortunately, I have seen a lot of people on code forces get hacked or fail system test when using this. In this post, I'll explain how it's possible to break this data structure and what you can do in order to continue using your favorite hash map without worrying about being hacked. Okay. So the reason it was failing is because I used map and nothing else. It's fine. So how they are hackable? We always assume hash map are one per operation, insert, erase, access, etc. But this depend on a key assumption, which is that each item only runs into O of one collision on average. If our output data is completely random, this is a reasonable assumption, but this is no longer a safe bet when the input isn't random. Especially so if someone is adversely designing inputs to our code, aka hacking phase. In particular, if they know our hash functions, they can easily generate a large number of different inputs that all collide, thus causing an O of n square blow up. Great. This is something different. We'll prove how we'll prove now by blowing up unordered map. In order to do that, we first have to determine exactly how it's implemented. For this, we can dig into GCC's implementation on GitHub. Okay. After some searching around, we run into unordered map.h. Inside the file, we can quickly see that unordered map makes use of detail mod hashing and detailed prime rehashing policy. From this we can guess that the map first hashes the input value and then mods by a prime number, and the result is used as an appropriate position in the hash table. From this we can guess that the map first hashes the input value, okay, and then mods by a prime number, and the result is used as an appropriate position in the hash table. Some further searching for prime rehashing policy leads us to hash table this. Here we can see that there is an array called prime list, and the hash table has a policy to resize itself when it gets too large. So we just need to find this list of primes. And there is an array called prime list, and the hash table has a policy to resize itself when it gets too large. So we just need to find this list of primes. The one included on the file leads to this. Aha, here is the list we are looking for. The hell, man, what the hell. One more thing we need to know, hash function. An ordered map uses before modding by these prime number. It turns out to be quite simple. The map uses hash, which for integer is simply the identity function. Armed with this knowledge, we can insert lots of multiple of one of these prime to the map in order to get n square blow up. These primes to the map. Not all the prime work though. Due to the resizing policy of the map, in order for a prime to work, we need the map to actually resize to this prime at some point in its set of operations. Not all the prime work though. Due to the resizing policy of the map, in order for a prime to work, we need the map to actually resize to this prime at some point in its set of operation. It turns out the right prime depends on the compiler version 6 or earlier. This does the job, and for GCC 7 or later this will work. Run the code below in custom invocation and see what output you get. For x is equals to this, it took 7 seconds. For x is equals to this, it took Depending on which compiler version you are using, one of these two numbers will take much longer than the other. There are several other prime that also work. Try some more of yourself. Note that for other hash tables like CC hash table or GP hash table, C chilies, it's even easier to hack them. These hash tables use a modulo power of 2 policy, so in order to make a lot of collision occur, we can simply insert a lot of numbers that are equivalent, say modulo 2 to the power 16. Oh god, obviously this is taking 7.5 seconds and this is taking 0.30 seconds. Insane. The output is same, but for this prime it's 7.5 and for this 0.030. This is just weird as it gets. Now let's don't want to be hacked. Let's look at how to safeguard these hash maps from collision attacks. To do this, we can write our own custom hash function which we give to another map or GP hash table, etc. The standard hash function looks something like this. However, as we mentioned, any predictable deterministic hash function can be reverse engineered to produce a large number of collision. So the first thing we should do is add some non-determinism via high precision clock to make it more difficult to hack. What is this high precision clock? Making randomized solution unhackable. Awesome. So our hash function is perfectly safe now, right? Not so fast. All we have done is add the same fixed number to every input to the function. But if two numbers, say a and b, satisfy a is equals to b mod m, then x plus a plus x is equals to b plus x mod m for every x as well. Similar problem occur for other very simple hash function, multiplying by a random large odd number and overflowing, but will be problematic for GP hash table. So power of 2 policy, the same situation occurs for XORing with the random number. Personally, I like to use high quality and fast. Credit goes to this. Adding all this together, we have a safe custom hash function. So unordered map, custom hash, and this is what the custom hash is. My god, I need to save it somewhere. Oh, holy. Now Okay, it went on to test. Okay, 106, 127, 138. Oh my god, how many test cases are there, dude? Okay, this is something insane. Um, I just don't know what to say, man. What to say? This is something insane. I need this. I need this at any cost. I need to save this. We save it in packages, user. This is my CPP snippet. Uh, you know, this. We bring something like this, right? What is this? Tab trigger is custom hash. C++. Safe hash. Should be making it safe hash. Safe hash. Sublime hyphen s and IWPET. Sublime hyphen snippet. Put it. It will bring the custom hash. Or maybe I can make it safe hash. Safe hash. Safe hash. Insane. This is just insane. Finally, it got accepted in time lesser than 2 seconds. But something I got to learn. If you used this addict, you were mostly likely hacked. You were most likely hacked. Great. But this was amazing. I got to learn something new. That even unordered map can be hacked easily, which I don't want. So, okay. Not. Let's jump to the next question. Let us see. Lulia, Luila, Lulia, Lulia. Lulia has n glasses arranged in a line. Okay, there is an array of size n arranged in a line. The ith glass has a of I unit of juice in it. The ith glass is 0, 1, 2. The ith glasses has a of I units of juice in it. Julia drinks only from odd numbered glasses, while her date drinks from even numbered of glasses. Okay, while her date. Okay, to impress her date, Julia wants to find a contiguous subbarrier of these glasses such that both Julia and her date will have the same amount of juice in total if only the glasses in this subarray are considered. So in total, if only the glasses in this, please help her do that. More firmly, find out if there exist two indices LR such that LR belongs to 1 to n, and if L and R have the same parity, and a a of L plus 2 plus 4 plus dot 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 a of r is equals to a of L plus 1, means sum of all the evens are equal to sum of all the odds. Output yes if there exists a subarray satisfying the condition and no otherwise. You can output the you want to find a contiguous subarray of these classes such that both Lulia and her date will have the same amount of juice in total. Same amount of juice in total. If only the classes in this subarray are considered, please help her to do that. Okay, let's see. An integer, the amount of juice in each glasses. The first line of each test case contains a single integer. The total number of glasses. There are total of 3 classes, 1, 2 and 3. The second line of each test contains an integers, the amount of juice in each classes. So the amount of juice in this class is 1. This class contains 3. This class contains 2. So that means I need to keep track of it's not even or odd that we are talking about, it's something. Okay, so every time this will happen, something will change, means I need to find a contiguous subarray, right? Correct. So if this is taken 1 2 3, so if we take all Lulia has to drink this, and this, which will be nothing but 3. And if we take even, this, and this, which will be nothing but 3. So I only have to see out yes or no that it is possible or not. Let's see the third example. In the fourth test case, it is saying 1 to 11, 4, 1, 5, 1, 2. So I need to find a contiguous subarray. If I take, suppose, like, what will be the brute force approach for this? Consider whole, then this, then this, then this, then this, then this, then this. It'll be something like that. Means 2, 3. I'll pick this and then try compare with everyone. Then I'll start with 2 and then try compare with everyone. That is what my brute force approach will be. Now I need to try to balance it out. If someone goes bigger, I need to do something. From 2, 3, 4, 5, 6, 7, 8. From 2 to 8, if I take this subarray, Lulia will drink what? Lulia will take 2 plus 4 plus 4 plus 5 plus 2 plus 5 plus 2. It's 13. And now this plus this 11, 12, 13. And this is the case that we want my sub array to have values something equal. Now how can we approach? We can take a subarray. Maybe we can take a subarray and find something. We take this. Obviously, I'll start with 2 elements, and somehow I need to compress. Continuously go continuous, or so suppose if I have 2 variable even sum and odd sum, and an odd sum, I'll start with these 2. So the odd sum will be 3. If I have two elements, this is 1, this is 2, so this is an odd, this is even, right? So this is odd, this is even. Now if I add a third element, suppose this odd is less, if I add another element, odd will increase. The total size is 3, sub-array size is 3, so the last element will be an odd number, so I'll have to add it in my odd. So it will be plus 11, which is nothing but in total of 12, so they are not same. My even is less, I'll add even, that is 6 and 12. And 12, then I'll add odd again, that is 13 and 6, then I add even again, I'm adding odd even, odd even, odd even 5, it's 11 and it's 13. If I add odd again, 14 and even again, it's 13 and it's 14. No, I need to somehow, I need to know. I need to figure out how. I need to figure out how. This is going odd and even, odd, even, odd, even, odd, even flow. The flow is something like this. I need somehow this flow to stop. Like what is the condition? Like some threshold should be there that okay, I'll not cross a sum to be this. See, the sum of n overall test cases does not exceed 2 to the power 5. If it is not increasing 2 to the power 5, I need to have some threshold. I need to have some threshold which will stop me that okay, this is the maximum threshold that I can sum up to, and if it increases, if it goes beyond, I'll have to do a sliding window minus. Like suppose if my sliding window says, threshold says that maximum sum I can take is 5, whether it is even or whether it is odd doesn't matter, the maximum sum I can take is 5, suppose. So in this case I'll have to have something. It is possible or not. If it is not possible, should I reduce the threshold value or should I increase the threshold value? What should we do? Based on that condition, can we think about how if whether it is possible to increase our threshold value or to decrease our threshold value based on some condition? Now suppose 5 is my subarray. So I'll take the first one which is odd, I'll add it in my sum. I'll take the next one which is even, I'll add it in my sum. Fine, still my threshold is not. Now the next element, the size is 3, that means this is going to be added in my odd, and my threshold has went beyond if I'm adding it. That means this subarray can't be taken. We cannot take this subarray if threshold goes beyond. Threshold is going beyond, I cannot take this, so I'll start from here, means this we discarded this. I'll start from here. I will check. I'll start. This is also increasing, my odd will increase. Then I'll start from here. This is my first odd, and it is in my threshold value 4. So the next value is even 1. This is also in my threshold value. So the next value is odd. We'll add 5 to it. It's going beyond. Nope. So we can't take this. So we'll start from 5 as my odd. The next number is 1. Even the next number is still again going to be 7, which is not possible. So this is with a threshold value 5, we can't make it. So in this case we are increasing the threshold value. Okay, let's take a bigger value. And while taking a bigger value, but in some case it might be possible taking a threshold value small will help me. It's like if my threshold value was 5, now the elements were 4 4. If my threshold value is 4, it is possible. See, these two array can be taken in account, so it's possible. So when to reduce my threshold, when to increase my threshold, it's not very much fixed. Is it fixed? How to decrease or increase our threshold? Is there any condition that on the basis of which we can decide? If it is not possible to make a sub array with this threshold value, Might be possible I increase the threshold value. Might be possible that I decrease the threshold value. Correct. But when to increase, when to decrease? How? Or is it something kind of merge sort where is this half and this half also, both half? And make it this as a threshold value and make uh, go with this half also and go with that half also, and wherever from wherever it will come. So like if my threshold is 13, how my sliding window is working? The first element that we take was odd, 1. Second is even, 2. Third is odd, which turns out to be 13, still possible. 4 is even, 6 still possible. Next next if I add 4, this this was not 4, 1 and 5. So the next element that will add is 1. If I'll add 1, it'll go beyond 13. If it is going beyond 13, that means what? I need to reduce. So if I reduce some value, I'm adding this also in my answer. So 11 plus 1, 12. 12 plus 4, that is 16. 16, and until and unless it boils comes in the range of 13, I'll reduce it from behind. If I reduce this 1, what will happen? Something will change. If I reduce this 1, my even will become wait a second, something wrong, I did something wrong. Odd added, even added. Next comes odd. Let's take this as 5. Let's take this as 5 and then 1. For suppose the next element that we will be adding is 5, which is going beyond 12 plus 17. So it's total 17, and I need something to go back. So if I remove this value, now what will happen? This sub-array will boil down to this, where my even will switch with odd and odd will switch with even, and from odd I'll reduce the value. Now the array size becomes even. So what will happen? 1 will be reduced from here, so 11 plus 5, that is 16. So now even will be 16 and odd will be 6. So the next value that will be removed will be removed from even, so 2 will be removed from even, that will be 14, and then switch up happen again. This will be 6 and this will be 14. Correct, if my array sub array becomes something like this. 16. 7 5. Do we have to switch up the value? Even will be 16 if this array is considered. Odd will be, now again odd, from odd value will be reduced, not from even. Always odd value will be reduced, so this will become 4, and again switch up will happen. This will go here, this will come here, and for this is 16 and this is 4. 11, so it will be 5, so 5 will be here and 4 will be here. 4 is odd and 5 is even. Okay, let's take a 10 minutes of break, and then I'll be back. I'll try to solve it This is something cool. Sophia and the last operation done. This question, for this I need to find a threshold value. How can I find a threshold value or move the threshold value here and there? Find out if there exist two indices L and R. Should be one and how can we do this? Any idea, chat? The sum can go up to 10 to the power 5. Hmm. Is it something else? Instead of thinking of contiguous subarray, can we think of some other approach? Is it possible to think in some other way possible? See, obviously, even odd. The odds will be picked. The events will be picked by her date, and the odds will be picked by her. So the array size will be either even or even minus 1, that is odd. Correct. Maybe I can think of something like this. Maybe I can think of something like that. Maybe. Let us see. Let's clear this out. This fourth 1 to 1 to 11 4 1 5 1 and 2. Now let's add all the odd and add all the even. 12 12 13 114. If I go for odd, the total sum is 14. For even, 11 13. So now the total length is what? 1 2 3 4 5 6 7 8. Right. Either I can reduce values from here or I can reduce values from here. right? Two, three, four, five, six, seven, eight. If the if the array size is even, I can see the first value will be odd and the last value will be a even value. And if array size is odd, if array size is odd like 1 to 1, see the first value will be odd and the second value will be odd. So whichever is lesser, I'll pick that and reduce that in my array. Now suppose it's an even, they are not same. I need to reduce which value to be reduced. I need to reduce the odd value. Correct. I need to reduce the odd value. So I'll pick odd. Just a second. So, so I was saying that if the value is odd, I need to know, like, if the array size is even, I know the first value is odd and the second value is, so in that case, if even is greater, I'll reduce this. If odd is greater, I'll reduce this. Fine. So in this case, odd is greater. So I'll reduce this and move my array till here. So this will be my array, array size 2, 11, 4, 1, 5, and one value will be reduced from odd by so one value will be reduced from odd, and after reducing one value, what will happen? This is my subarray. So now the odd will switch. The whatever earlier was even, now it will become odd, and whatever earlier was odd, now it will become even. So the values will switch, 13 and 13. Now they are same. So something using this approach we can go, instead of thinking of threshold, we can do something like this. Okay, let's take a better example in order to understand. So for the last one, it's something like this. Let's take the last. Let me change the color. 2, 5, 10, 4, 4, 9, 6, 7, 8. So this is my array. Now I need let's take the odd sum and even sum, initial odd sum and initial even sum. So this is my odd. 2 plus 10, 12, 16, 16 plus 6, 22, 22 plus 8, 30. The odd value is 30. Now even 5 plus 4, that is 9, 9, 18, 8, 18 plus 25. So even is 25. Now currently the array size is 1, 2, 3, 4, 5, 6, 7, 8, 9. So array size is odd. Odd array size, that is 9. Now I know if array size is odd, so the first element and the last element both will be odd. Right? This is for odd and this is for even. So if array size is odd, the first element and the last element both will be odd. So I can reduce any of them. So I'll pick a smaller value. Correct? I'll pick this value and I'll reduce that value from odd. That is, now it will be become 28. Now my array, now my pointer will be from here to here. Correct? Now what will happen? The values will swap. Now 28 will be here and 25 will come here. Why? Because starting from here, this will be odd. 5 plus 4, that is 9. 9 plus 9, 18. 18 plus 7, that is 25. So 25 is now my odd number and even will be 28. Right? So this is what happened. Now my even is greater. I know, and my array size is 1, 2, 3, 4, 5, 6, 7, 8. My array size is even. Array size even means the first element is odd and the last element is even. So I need to reduce value from last element. See, if I reduce the value from last element, what will happen? It will reduce to 20. Now this time my swapping did not happen. Why? 3, 4, 5, 6. Because I removed something from last. The ordering did not change. So this is for the fourth test case, not for the last test case. Let's see what happens at the last test case. Now array size is even, then start and end will be, this will be odd and this will be even. Means I need to only take care about the last, because the start element will always be odd. So if the array size is odd, last element will be odd. If array size is even, the last element is even. Correct? In both cases, odd, even, odd. Now let's see. My odd is greater. I need to reduce odd. See, the array size is 1, 2, 3, 4, 5, 6, 7. Array size is odd. So both side is odd. Which one to pick? Which one to go for? I'll go for the one which has the lower value. So the value lower is here. Will that make sense? Possible. No. If both are odd, which side to go for? If possibly this would have been 4. suppose if this would have been 4. Now what will happen? If I reduce this value, it will be 20. But in this case, I'll reduce this value, which will be 4. No, this will not give me a optimal answer. Which value to reduce at this moment when I need to reduce odd and I have the array size as odd? It will not give me an optimal. Because here this is smaller, I reduce this, but might be possible that this is smaller. Which one to go for? Which one would you go for? So I need to check for both. Reducing this also a case will occur. Reducing this also a case will happen. That means we'll have to go for some dynamic programming question approach for this, some kind of DP approach. Hmm. What can we think of? Either I can reduce this or I can reduce this. Possible. We'll have to go for a recursive approach here. From what I can see, this will give is it of divide and conquer? There is no question for divide. DFS and similar. What type of tag is this? Data structure it's a greedy and math. It is somehow greedy. But how? It is somehow greedy. But in this case, for this case, what I will do if air is 4 and suppose this is 7, so obviously my odd sum will be 5 plus 7 12, 12 plus 9 21, 21 plus 4 that is 25, and the other sum is 20 and this is 25. Which one? If I reduce this, that will not give me an answer. It will be 21, but if I remove this, it will give me 20. How it is greedy? How? How it is math and how it is greedy? Hmm. Okay. AFL plus 2 4 plus 1. So AFL minus AFL plus 1. This is some how need to be 0. From here it's clear that we need to find if there is a sub array with alternating sum equal to 0. Let's flip all elements on even indices. 8 minus a2 a4 minus a4, then alternating sums of so sub array sum equals to 0. It's a hashing prefix, it's a prefix sum. This is a standard problem with prefix sum. If two prefix sums are equal, then the subarray between them has a 0. Otherwise, no sub or analog and dependent. How you check if two elements? Be careful about using hash tables as they can be hacked. Great. Don't you think? That this is possible. So make alternate elements negative. 2 minus 5, 10 minus 4, 4 minus 9, 6 minus 7 and 8. And now find a subarray. Sum equals to 0. So 0 at 0 index. Sum is 2. Is 2 present? No. I'll place 2 at 0th index. So like at minus 1. Minus 5, which is coming out to be minus 3. Is minus 3 present? No. Minus 3 with index 1. Plus 10 will give me 7. Is 7 present? No. 7 with index 2. Now minus 4 is 3. Yes, 3. Is 3 present? No. Minus 3 is present. So 3 with index 3. Now 4. 7. Is 7 present? Yes, there is a 7 at index 2. 0, 1, 2. From here till here. Weird, huh? Wait a second. So make A2 as negative, A4 as negative. So A1, A2, A3, A4 dot dot dot. It will go something like this, right? So A1 to minus 5, 10 minus 4, 4 minus 9, 6 minus 7 and 8. 0 sum is at negative 1.
Now summing up. 2. 2 is there? No. 2 at index 0. 2 minus 5, which will give me minus 3. No, so minus 3 is present at index 1. Plus 10, that is 7. So 7 is 5, 6, 7, that is 3. 3. No, 3 is not present. No, it's 7 here. So plus 10, that is 7. From here till here, what I can say is 14 minus 4, that is 10. You can see the value came out to be 10. But there is no subarray. The sum equals to 10. There is no subarray whose sum is equals to 0. Values can be negative and positive both, right? Even I'm doing the same thing. What wrong I am doing? That I don't understand. Subarray with if sum becomes 0 or sum of set dot find sum is not equals to sum of set dot end, that means we found that value, so return true or insert sum. That's the simple thing, that's a simple logic that I wow. Why I'm so much in confusion. Why I'm not able to understand the logic here. Can I take another example? Any better example? Let's take this. This. So 42016. So 0 as -1. Sum is 4. 4 is not there. 4 with the index 0. Sum is 6. Okay, so the leaving this element of oh my god, okay, so we after this index the values that we are getting is 4 minus 4 plus 4. If we take this, great, and I'm using romantic classes. CPP default. So what are the inputs that we are getting? Array size and the array. We are getting the array size and the array what is the size of the array? declare a vector int maybe nums of size n. Now hash map can be hacked, so I need to be careful about that. Safe hash, I should use safe hash for that. So C in nums of I. Now what should be the output? It should be yes or no, simple. So I solve, in solve I will even, can I directly paste if int val, let's take val c in val. Now if I is equals to I modulo 2 is equals to 1, that means it's odd. So nums of I will be equals to val into my -1. And solve simple nums. Okay, I will get a vector ampersand num. Now I need a safe safe hash, unordered map integer. I only required integer safe hash m of 0 is equals to -1. Should also pass n pass n. Some plus is equals to nums of I. Now if m dot find sum is not equals to m dot n, if m dot find sum is not equals to m dot n means we got something. So I'll simply see out yes and return 0, else I'll put it in my map. This sum is equals to I, and at last I'll see out no and yes, return 0. Let's see. All are yes. Okay, this shouldn't have happened. Third and fifth are no, dude. C out nums of I. Oh, if that is the case, else I did not do nums of I is equals to val. No, no. Submit and let's see. Wrong answer on test 3. On the first token of test 3. This is the test 3. Numbers. The numbers are very big. It's the same thing. I need to take LL. Sum is LL. Map is LL. Take this also LL. This also LL. Everywhere LL. Maybe this also LL. That doesn't matter. Let's try now. No, accepted. It was LL problem. long. So this was also not that difficult. The only thing that I needed to understand was the math that was hidden behind this question. This math, I was not focused on this part. I was more focused on how to approach this. But still, finally, I was able to. Okay, so I think I'll stop here because I have to go outside. I have to finish some work. I did not finish it yesterday, so I have to complete it now. So I'll be back. Most probably next week I will not be streaming because I'm going home. So I will not be there, but I will do LinkedIn post still. So today we learned a lot of things. Now I got to know how unordered map can also be hacked and how to stop that hacking. So that's really one of the good thing that I got to know. It's really nice. The questions are really nice. The level is really nice, and slowly and gradually I'm able to grasp things. It's very slow. I know that it's very slow, but still I am trying my best. So I hope you guys also enjoyed the video. We learned a lot. We got to know a lot of things. Hope to see you in the next stream also. When I'll be back from home, I'll do more stream. So see you over there. Bye bye. Thank you so much for watching. Do like and share and subscribe my channel for more such content. Bye bye.